All right, everyone. So today and this week, we're focused on object-oriented programming. So who can kind of summarize to me what's their understanding of object-oriented programming is so far? Object-oriented design. Want to take a stab at it?
From what I understand, it's like, well, when you define like the class, such as like you have, oh, I just give example on like as a human we can or as a person, right? And then on person has a name, has a height, have a different like characteristics like that. And person is
Oh goodness, this is horrible for recording.
as a OP, like person like they can change any character like attribute on the underneath of like person, but the person is only the same like same type. It's like same as an animal. It's an animal is only one type, but they can be different name of animal or like different attribute. That's kind of like the concept. How to implement it that's like how to do that. I don't know how to get a class and
Okay. Right. So kind of in hearing what you're saying, a lot of it is around developers thinking through solving their problems through the scope of a problem being around objects and how those objects interact with each other. The idea that anything that we're building is an object and that objects can respond to particular messages, and how those messages and objects can do that work that needs to be done together. That's the kind of concept of object-oriented design. Other concepts of design might be like functional programming, right? Thinking about everything as a function, not that things have objects and that they have particular attributes. It's more like a larger like systems thinking, right? And then everything else from there is implemented through that perspective of things being an object, and that objects have a particular way of behaving based on the way that we design and develop our programming to work. Okay?
Using functions within objects.
Mm-hmm.
You know, there's also implementing sort of functional programming. Maybe I still understand this. The nuance difference. Where is there? It just seems like there's functional programming and object-oriented programming does functional programming and then some more stuff.
So when we think about object-oriented programming, there are obviously methods that would need to like do things, right? Like it doesn't necessarily mean that functions don't exist, right? Methods exist in object-oriented programming, right? So just because there is what we would think outside of Ruby as a function, just because we have things like that in Ruby doesn't mean that we are doing functional programming necessarily there. It just means that you have to. So any programming language is going to have a way in which some kind of logic is implemented. Okay, but that doesn't mean that the way that we implement those logical steps to happen, that those are being done in a functional, like with the implementation of functional design. We're thinking about it in terms of objects. Does that help answer your question a little bit? I feel like you're still mulling through that a little bit. I think it'll become a little more clear like much later along the line, but just think about everything that you're building is going to be implemented from the perspective of looking at your work through the lens of your program having they're being designed as objects, right? All the pieces of your program are going to be designed through the scope of an object having a particular behavior and can respond to some things, whether those are methods or attributes or variables, as we're going to talk about that right now. And some things do not respond to other things. And then those things being objects, right? Objects can communicate with each other in particular ways. They can be related to each other in particular ways, and they can have access to specific things, either as something that can be modified in write, or just like understood in read, or accessed as both of those, like read, write, right? But the focus of this conversation that we're having right now is going to be on scope. So I'm scoping our conversation to scope, okay? So particularly with Ruby, there's a certain set of ways that we distinguish what we can do in terms of our variables, and that is set up through scope. Okay, so let's start with the smallest scope possible. Okay, and that is a local variable. Okay, so a local variable is something that is defined and available only within the current and immediate scope. So if we have some method, okay, and then if something happens, right, and let's say we named variable equals here, okay, and then we tried to call local variable here, or we tried to call local variable here. Okay, what do y'all think will happen? Where do you think the error would be? So let's try and implement some method. Okay, so if we ran this method, what is the results? Let's see. Ruby scope. Okay. Oh. Let's see. Sure. Okay, so we get the error. First we get high here, right? Because we ran this here. Okay, that's the only time we get it. The rest of the content we see here, y'all can see that. We have undefined local variable or method local var on line 10. So I tried to call it here. It couldn't find it, right? And that's because we're trying to call it outside of this method, right? Okay, so let's erase that and see if we get another error. We didn't, but we didn't get it twice. We did get it twice. So if end, even though we set it here, we defined it here. So an if block an if block should be its own local scope, from what I understand, but it's still allowing for this information to get put outside of this block, even though it's defined inside this block. What? Okay, that didn't give me my appropriate example, but outside of this method, local var cannot be called, right? Because it's defined inside the scope of this variable or this method. Additionally, if we tried to ask for, if we created a class, right? If we created class dog and we had no adder readers, but in our def initialize, we set up some information like name equals okay. So if we created a dog.new and we tried to call the dog's name here, we wouldn't get Fluffy, right? What do y'all think? Thoughts? So in this case, right, we set this as a local variable. There's no indication that it has any other scope than where it's defined immediately. Okay, so it's only available within the block of its initialization. Additionally, the local variable will raise an error if they're read before they're created. Okay, so if I said, for example, name equals birthday, right? And then it's initialized, and then now that's going to think of it as a method. So in this case, let's just look at this case. Oh, that's anything. My dog. Oh, so I've got my dog not due, and then I want to ask for my dog dot name, right? So in this case, it's saying there's an undefined method name for dog because I'm calling it using dot notation, right? How would I be able to allow for this variable to be read from here?
If you use dog.new.
It's the same thing here. Because first we're defining this variable as a new instance of dog, right? We're trying to call name on it to be able to get information, right? In this case, we're trying to call name. And even in here, if I say, more. So let's say, so typically when you want to access something where you want to call a method, you have to be able to make sure that, actually, might just work. Let's see. So instead of calling .name, let's call .bark. Okay, so I'm calling this bark method, which dog should be able to have access to, right? But I'm trying to use this name method inside of another method. Okay, even though it was defined within the scope of initialized. Okay. Different. So much extra end. Okay, so in here it's saying there's an undefined local variable or method name utilized in bark. Okay, even though we initialized with this variable, bark can't have access to this variable because it was a local, it was defined as a local variable. Okay, if we wanted to have it set as like give it a larger scope, okay, the next up level of scope is an instance variable. Okay, so if I wanted my entire instance, my dog here, to have access to this variable, I would need to have it have an @ symbol. Okay, the @ symbol indicates that it's an instance variable. Okay, what that means is that it is now available to the object of its initialization. Okay, so that means that name has gone from the scope of just here to now this entire initialization. So whenever I initialize, now if I called .bark here, oh, okay. Why do you think this happened actually? Right, so there's two ways in which we can make sure that this is accessible, okay? Because here, with it not having an @ symbol and us not having a reader, okay, we're saying that we're talking about name locally scoped to this method, okay? Until we give it access either through setting an adder reader here, okay, which is the equivalent of what? What would I do if I didn't do adder reader? Can somebody tell me how to? I would make a method, right? It would be called a getter, okay? Getter is only saying, get me this data as a method, right? So then it would look like def name, right, equals @ name. Okay, so instead of me creating an entire method only to get the instance variable, I'm setting an adder reader. God, am I typing? Okay, so this line is the same as this here. That makes sense to everybody? Okay. So now that I have this, I can call name. It's going to refer to getting this item. If I didn't do that at all, I know that I can also explicitly call the instance variable in any other method I'm using within the class using the @ symbol. Okay? So now if I run that, Fluffy says bark. Success. Thank you, Fluffy. Okay? This, so the hashtag in the curly braces in this point is just for string interpolation. So this part is basically reaching out of this string and getting the variable, the value at that variable, and replacing it in this string. Right, I removed the adder reader here at the top, see? So if I put adder reader here, okay, then I don't need this @ symbol. Because basically it's coming out and saying, do I have access to something named name? I do, only in read, okay, only read access, so I can do this work. And I'm not pulling the instance variable in itself. It's like set in its own method. Okay, and it does the same thing for says Bart. Okay, so one of those two things you would want to do.
You want to overwrite name using the letter writer or accessor. Are you changing the name? Are you changing the name for every instance going forward that you've already created?
Good question. So maybe for an example, for clarification, you're saying like, so right now I have this one instance called my dog, right? And in this case, I explicitly named Fluffy in here, which doesn't often happen, right? It's usually like, you know, not every instance should be named Fluffy, right? So this is not necessarily a good example. But if I wanted to change the name of this to be whatever, right? And I wanted to make sure that that was accessible. So let's say, let's just make it an adder accessor. Okay, so my dog, dog bark, I'm fine with the name Fluffy, right? But maybe your dog is new, and then you want your dog name to equal what's your dog's name? What do you want your dog's name to be? Your dog's name is Gary. Okay, so then if we ask your dog to bark, our expectation is that we should get Gary says bark, right? Would you say that's true? Okay. So we had my dog bark and your dog bark, okay? In this case, because it's an accessor, we were able to set the named attribute as Gary, right? So then it is utilizing that information for name. Now, we already changed that information with your dog, right? Here. Yeah, in the case of the fact that every instance of dog right now, we set it so that it has an initial name of Fluffy.
If you remove the accessor, can you change the name with that outside of it?
Like remove this entirely or remove it to
take that out and then you try to do the name without the add.
Well, right
so
now,
like if you go like back to the command line, you did, or not the command line, but what at the very bottom, you did your dog at name was Gary. That's what.
oh, can you use at here? Is that what you're asking? Yeah. Good question. I want to say no, because that is not normal. Okay. Let's do that. Okay, so we don't even need that my dog's bark right now. Okay, so yeah. So that wouldn't work. Okay, so you can't call an @ symbol. Yeah, it's a variable. So when we call .name here, we're actually calling a method that's pulling this information. right? So when we do adder, remember when we do adder anything, okay, this symbol is reflecting a method that is like invisibly being created, right? It's replacing the fact that in order for me to get this information outside of the class to be able to actually call it, because I can't call @name as we just saw, right? In order for me to actually call it like that, I would have to make a method called name, and where it would return to me the attribute name, right? Or the accessor is basically, it's like name equals, and then @name equals name, right? Like that's what's happening when I do an accessor and I'm trying to like both, when I'm trying to set it, that's what's happening, right? I'm saying change the attribute, the instance attribute that I have to the attribute that was given to me, the value that was given to me, okay? And then when I call it, I'm calling this method, I'm not calling the variable. But what's being changed is the information about that variable. Does that make sense to everybody?
Yeah, so just like in this case, since you're instantiating an object, initializing with the name, you wouldn't be so specific generally. But like use fluffy, right? Like just you just go name @name, right? So it's going to initialize name, not a specific name.
Right, maybe I would have a method that, yeah, so then I could say like a dog's name will be given to me when, and it will be held in this attribute called name. And then once that's set, I can do other stuff with it. Right? So then, yeah, so it just maybe gets instantiated as like nothing at the moment. Okay? So instance variables, again, the variables themselves start with the @ symbol. That means they are accessible to the entire instance of that object, okay? And they're used pretty commonly, right? As we've noticed. Okay, class variable. So I'm gonna do another example. Class. Okay. Okay, so we have a ghost class, right? Where we have an adder reader for name. And then, so it starts with the name, like when we instantiate a ghost, we instantiate it with a name. And then we have @name equals name, not minus, equals name bar. Okay? So that's the example of what we already kind of talked about, right? Now, the next scope outside of an instance is a class variable. Okay? So kind of alluding to what you talked about with like my dog and your dog, like if you change the name of your dog, will it affect anything about my dog, right? It won't, because those are two different instances of the dog class, okay? But a class variable will give access to a variable for the entire class, meaning that every single instance of that class will have access to that variable. Okay, so class variables start with two @ symbols. So what we'll do is we'll create one here. Okay, so class variable might be an example like this, right? So for the class ghost, right now there are 0 ghosts in the world because I have not created any ghosts, right, in my ghost class. Or for ghost class, there have been 0 instantiations of ghost, right? So then maybe for when a ghost gets instantiated, right? Which means when initialize gets run, okay? Not only am I getting a variable for the name, but I'm also updating ghosts in the world to 1 up every time, okay? So then what I can do in this, okay. So then I can always ask, like maybe the ghosts can always, like a ghost can always ask, how many other ghosts are there, right? So I can create a method called how many ghosts, okay? So here I'm just returning that number, okay? So that means what I'm doing is that I'm providing every instance of ghost the ability to ask, like, who else is up in here in the world, okay? So let's say we make a ghost, ghost dot new with the name Carrell. And then maybe I make another ghosts scare people, right? Okay, now, why can I do name by itself? Because I haven't added a reader, right? Not just because I initialized it here, but because I have this add a reader. Okay. Who else wants to be a ghost? Deja wants to be a ghost. Okay. I should do that as well. Okay. Who else? I'm gonna make John a ghost because he's not here. Okay. So if I asked here, Kara, how many ghosts? I should get something different than how many ghosts here, right? Y'all see why? Okay. Okay. So here, so every time that's happening, okay, I have one ghost that was created, right? That's the object ID for this ghost. It went up 1, right? Then this next instantiation got created. Notice here and here, these are different IDs, okay? When you create a class in itself has an object ID, okay? So those are different instances of that object, okay? And then in our initialization, we are setting it so that there's a a class scoped variable that's being incremented up every time there's an instance being created. And that one variable is being given access. Every instance of that class now has access to this larger set of information. In this case, only one variable, right, for every single instance of that class.
That's really so obvious to me. I mean, it's a compiled language, right?
Yes, this is a compiled language.
So, like, the data is already available for the, you know, when you run Ruby scope v, it's already available that there's 3 instances created. So why isn't it like something that's like hoisted to the top of?
The hoisting is not what's happening here. So in Ruby, things are run chronologically, basically, as it's been written. Okay, so this information is not like as it's run here. Like if I just printed, let's see, ghost dot. What would I be able to call it before I call any of these things? There are class methods that allow you to get information about classes, which would show that there are, like, you can ask Ghost like what class it is, what kind of instance methods or other methods it has access to, and that would indicate to you that these things aren't available to it until an instance is created. Okay, so the only reason why this class variable is being modified is because there are instances being created of that for this file, right? And it's when this file is run, it both creates the class and instantiates these 3 objects. So if this file is accessed in other files, for example, okay, and we're creating ghosts in other files, okay, that class number should actually be a different number. It should be a larger number. Because it's for any time when this class gets created, anytime this class gets instantiated, no matter what file has access to it, it should, upon initialization, increment that number up. Okay, so just because I'm creating these ghosts in this file doesn't mean that, like, there might be other instances of ghosts that may or may not have already been created. Does that make sense? Yeah, so let's try that. So let's say touch all, let's say more ghosts starting. Okay, and then okay, so let's say require relative scope, right? And then I want to make another file, another thing called, let's make, what's another ghost? Let's see. Never. Gary died, so Gary's a ghost now. I'm sorry, your pet died. Oh, it's so sad. Okay. So then here we're running, we have scope relative here. Okay. No. So let's see. Let's see what we get. So if we run Ruby, what was it called? More ghosts. So now at the end it has 4, right? So now granted, we built this scope here, right? That was being printed from run. It was because it was here, required relative scope. So let's say I did that. Right, so even though this ghost was instantiated inside of this file, more ghosts, it still incremented up the larger class number of how many ghosts there were, right? These 3 ghosts were built here in this file. This one was built in this file. So anytime anybody would have access to the ghost class, right, from this file and would create more ghosts, okay, that class variable would increment up anytime it was instantiated. Yeah, if I run it now, it's only running one. It's only creating one, because in this case, this is the only time. Wait, say what? These are being commented? Oh, so we like want to print this in here?
I mean, because you said every time you create, it's going to be different inside. If you create like that, it's something like goes.
So
how many goes?
Yeah.
So this, yeah, because I commented back in, and if I look there, here. Okay, this is a good point. Okay, so these ghosts were created in the other file, right? That moves the count up to 4 because we had the 3 in the other file and 4 in this current file, right? But then here, I'm getting an error saying that there's an undefined local variable Kara. Even though I defined it over here, right? I have Kara here, it's being printed, okay? It's not defined within the scope of this file. Even though it's like relatively like created from that other file, okay? This I can't do here, okay? Because it was like a local variable. It's local to this file. There are ways to access, like obviously we had access to this class, right? But we didn't have access to these variables. These were set as local variables.
What if they're like exactly the same
Oh, okay, so then yeah, so if I did that here, so if I did say caret equals another ghost.new, right? Same thing, has the same information. Okay, so in the other file and in this file, I have a ghost instance that has the name Kara, and it was both given the local variable name Kara. Okay, it's in a different file. They have a different object ID. It's not the same ghost. So if I asked Kara here, how many ghosts? I should get 6 or 5? Should get 5. Right, so we created 3 ghosts on one file and 2 ghosts in this file. So that would equal out to 5, right? Okay?
One last thing, if you create like global variable on the original file on the scope file, instead of overriding it.
So let's try that out. So we talked about class variables, right? They begin with double at. They're available to the entire class in any method, okay? Again, they'll raise an error if they're read before they're created. We should avoid using class variables. There's not a lot of reasons for you to use, even though we showed you this, right? Like, we showed you like the power at which you have access to like something like this. There's really not a lot of reasons to implement a class variable, okay? For the most part, you would be utilizing instance variables or local variables, okay? You're not really ever, really rarely going to see in a time where you see a class variable, but it's useful to know that it exists, okay? Like, this is really the only time frame where, like, there's not really a lot of examples you can find of, like, why would you want to know something or give somebody access to that much information about an entire instantiation, or like the entire, every time a class is being utilized in some way. There's not a lot of reason to have information shared between instances, right? Okay. The larger scope from that is a global variable, okay? A global variable is available everywhere, okay? It is not good to use it, but it exists, okay? So for the example that we just dealt with, okay, we talked about, so this is an example of a global variable. This begins with the $sign, okay? It's available to the entire application. So the instance that we gave here, like we had Kara, we created a new Kara over here, right? But what if we did something where, what would happen if I did this? What do you think would happen if I ran this now? Okay. So if I did this, what I'm guessing is that on this side, and I ran this here, I guess I would have to do it like that. This should still happen. Right? What do y'all think? Think it will happen? I don't know, we'll see. Okay. Exactly. Okay, so on this side, I defined Kara as a global variable. So instead of it being a local variable set here, even though it's like outside of a class, right? Variables, like this is a Ruby file, right? So even by me just saying like Deja, this right now in scope is a local variable. There's no information before it. It's set as a local variable. Okay, that's why it didn't work on this file, because only in the scope in which it was in, like the where it was defined, that's the only place it lives. Okay, but now I made me a global variable. So now Kara's here, and I can just take what was existing over here, and now it exists over here. Okay. Additionally, what would happen if in here, because it's like literally available everywhere, what if I said, who is this? We'll see what happens if I do that. Okay, so except for the fact that I just defined it down here, we'll see what happens if this works. or if I defined it up here, let's say, would be a good global variable. I don't know. Okay. Okay, this is not even defined in this class, right? So what if I'm over here? One, I can call dead, right? But I can also ask any of these people, like Gary dot, who is this? Okay, so what just happened? I created Kara, ghost, that instantiated up to 1, and then I created 2 and number 3, right? And then we printed Gary, how many ghosts? I guess we can print out Gary too. And then I printed Kara.scare, which again was defined on the other file, but works on this file. Okay, I also asked how many ghosts. Okay, I also printed dead, which was a variable that I created over here. And in who is this, in class ghost, I accessed the value of this variable inside of a class, inside of a method, without dealing with it anywhere inside of it. Okay, that's like horrible, horrible access. Okay, like you should not, like, imagine if you did something here where like their dead was like something else in some other class on some other file, and now it like lives all over everywhere and can be accessible, and it's just like a lot of overreach. Okay, one of the things that we'll learn with object-oriented programming is we've already talked about, right? Single responsibility, okay, and decoupling. Like we should not have this much access to any kind of information. Okay, it could cause a lot of side effects that could be really detrimental to a larger program. So this is very much not something that you want to do. You will see in Ruby that there are some variables that are seen as global, but they're very, very, very rarely used. Okay. All right, so now we know we can get all up in all this stuff. The last scope besides global, okay, that we haven't mentioned yet, is a constant. A constant is still available within the scope of their definition. The idea of a constant is that is like mutable information, right? So when we were doing like Roman numerals, for example, right? Some of that information is static, right? We don't need it to change, but we need to be able to like, this is information, this is variable information that's not really going to change. You want to set it as a constant, okay? Constants are set as all caps. So that's how you would write it out syntactically. And it's still only available within the scope of their definition, okay? So if you did want to have some kind of constant here with your class, like your ghost class, for example, you would want to set it up to be like, you know, I don't know, I can't think of what a constant for a ghost might be. Huh, that's a good one. Okay. Okay. So you would set it up as a constant, all caps.
That's a method scope, class scope.
So it's within the scope of its instantiation of where it was defined. So here it would be, well, let's find out. So outside, let's leave this here. And we're just going to deal with scope, right? And let's not have global anything anymore. Okay, so let's say we had this one here, and then we ran scope. Dynamic constant assignment. Okay, so let's see. We get set. There. Okay, so this constant, it was not good to have it inside initialize. So what if I wanted to, no, not describe. Okay, so I think this process would require it to go through the same methods as like a local. It's similar to a local variable, but constant is saying that it should be an immutable variable, right? Like it's. So you would probably want to have it something where it's like add a reader here, like color.
We need like a component as well for that network. Class constantly.
Like a class attribute.
What was the error it was getting inside of the
It was saying dynamic constant assignment. Okay, so I'll look more into this error particularly and where you would want to specifically scope a constant, but you'll typically see something like a constant inside of a method, right? Where if I wanted to, well, you wouldn't want to call it from another method. You would call it within the method, right? But you're basically stating that this variable is constant. It's not something that you would change, right? So outside of that here. Okay, then let's put this. Yeah, I'll look up this particular thing, but just note that whenever you see anything in all caps, that it is a constant. Okay, constants in Ruby have particular way of behavior, so that's probably why we're getting this information. Just note that when you're trying to set up constant, that is going to have particular setup behavior. And I'll look up what the more specific rules are around like assigning a constant. But for now, get a better understanding of like what you should use. Again, you really should only be utilizing instance variables and down. Understand when you're defining things, how you can access them, and giving people or giving variables and methods and classes as little amount of access to things that they don't need access to. Okay, so it's always best to start with a local variable and then decide whether or not you need it to have a larger scope. Okay. All right, so today's work is there's a challenge called apple trees. So this will give you a lot of understanding about like what scope can do, like the power of utilizing scope. Okay, yeah, so your core challenges say there's only 2, but they're larger. Like, let's think about this as a whole. Like, if I were, you know, creating apple trees as classes, right? What would that look like? What would they need? How do I build methods that can do things for this apple? And thinking about the natural, you know, understanding of trees, right? They, you know, they're born, right? Trees are like, they start from a seed, they grow, they, you know, they give fruit, they die, you know, you pick apples, you know, all that kind of stuff. There's all these behaviors that you're going to want to emulate with this challenge. And then the other one is bowling, which has a little more of a, you know, obviously you have a start and an end to a bowling game, right? You have a certain set of things you can do in bowling game. There's rules to bowling, right? And then there's the act of, you know, bowling, getting a strike, getting a spare, that kind of stuff. And then how do you know if you've won? Okay. Both of these are going to have elements of like making sure that you have the appropriate scope set up, and just getting more used to thinking about emulating different things with the focus of object-oriented programming, right? So bowling, right? You have a certain set of things that behave a certain way. You can ask like a bowling game to do certain things. Okay, you might not be able to ask them to do other things. They should only be able to do a certain amount of things. And if either of them are like a little like hazy in terms of where y'all are at, you have basically all afternoon to do both of these. No, we're not going to get into these pieces. I might stop in the afternoon to talk a little bit about instantiating objects with hashes. Excuse me, which might come into play as you're building your program. You might see something that seems to be like there might be an easier way to do that, and that would be by utilizing hashes with object instantiation. But we'll talk about that in the afternoon. But for the most part, I want you to just focus on apple trees, and then I'll probably stop for like half an hour in the afternoon just to show you how to instantiate an object with hash. Okay? This is already 11:21. Make it happen. Okay.